Hi guys, Chris with Microsoft here with another exciting episode of What's New in Windows Server 2012. Last few episodes have been about Active Directory. We're going to move on to another topic of storage. We're going to be talking about some of the new enhancements that we have in Windows Server 2012. We're going to be starting off with a discussion about storage pools, which is part of the storage spaces inside of Server 2012, which really comes down to essentially disk virtualization. It comes down to creating basically a SAN out of, or at least a storage system out of Windows Server 2012. Now, in a SAN, obviously you have a controller. The controller is the brain of the operations in the SAN. It's basically a computer for all intents and purposes, and behind that you got a chiller box full of a bunch of drives. Now, this is poised as not a replacement for a SAN, but instead it's an alternative way that you could go for providing a storage solution. So as you saw, I clicked on File and Storage Services. This is another way to manage your drives and your storage pools and your iSCSI targets, which we'll be talking about later, and in this case, storage pools. Now I can also look at disks and volumes and here just like I can with the tried and true disk management. So if I looked in disk management console, I'm going to see a whole lot of drives in here. So I've got 20 gig drives, and I've got some 15 gig drives, and I've got a 126 gig drive, just a handful of drives of the same console that you've seen. This is one that's inside of Server Manager, and it does the same thing. Now what's really cool about this is if I'm managing a whole host of different servers, as we talked about in a previous episode, I'm able to manage their disks and their shares from this same console remotely without having to RDP into that system and then open up disk management there. To begin the process of creating a storage pool and really show you that this is not just another way of doing software RAID. This is a true intelligent storage subsystem. We need to kind of look at a couple of different places where we see drives in Windows. Now, one of those, as you can see, as we had just looked, was here in disk management. Another one of those places where we're going to see that is also going to be in the device manager. So if we go into device manager, we can physically see these hard drives are located here. So in the hardware stack, that's where we're going to see those. And we're going to see this at the store port layer or the volume manager layer. And then here we've got the view of this from a storage pool perspective. Storage pool will see these uninitialized drives in the primordial pool. And if you want to see all the disks in the unconfigured state, we would see those listed here under the primordial pool by having this highlighted. So what we do is first create a new storage pool. So this is a little wizard that's going to walk us through doing that. So all I'm doing in this first section is I'm going to go through and I'm going to create a pool of disks out of unconfigured disk primordial pool. We'll call this the storage pool 1. This server. Click next. And we're going to go ahead and grab some disks. So I can put different size disks into this pool. I'm going to leave that one alone for now. And the only other real choice we have has to do with whether this drive is going to be a hot spare or if it's just right here in automatic. So if you're familiar with RAID controllers, most RAID controllers give you the capability to add drives in to an array or give you the ability to have it as a standby just in case it is needed later. So that gives you the ability to have a drive that suddenly can pop online and become part of the array if necessary. So we're going to go ahead and click Next and click Create. And so as it creates this storage pool, we're going to see this pool appear, and it'll show you the disks that are in that pool. So this is the storage space that we've created. We've still got the other disk that we did not do anything with in the primordial pool. We'll probably do something with that here in a little bit. And that's all it really took to create this pool. So what did we really do? Okay, so we come over here to Device Manager. Really nothing going on here. You can see that there is no change from a hardware perspective. We still see these hard drives. But if I go into Disk Management, on the other hand, I don't see these drives anymore. They aren't here. So at the store port layer, at the volume management layer, you can see this is not software RAID. This is a true storage system. This is a true storage subsystem that is managing this. In fact, this is actually running via a new driver that exists at the same level where your volume manager is. And if we were to expand out the different storage controllers, you're going to see the Microsoft Storage Spaces controller. So if I go in there and look at the driver and see the Microsoft Storage Spaces controller, and even go into the driver details, you'll actually see that this is called Spaceport. So officially Microsoft has a Spaceport, and the driver that controls the storage spaces is what is the brains of this operation, which brings us true disk virtualization. So I like to bring this up and show that this does disappear from disk management, because now he's controlling this. So obviously just having a pool of disks isn't terribly useful, so we need to do something with this. So we're going to create a virtual disk. Now the word virtual essentially means fake, just like virtual machine. That means a fake machine. Virtual memory means fake memory. We're going to create a virtual disk. This has nothing to do with virtualization from a virtual machine standpoint. This is disk virtualization. If you're familiar with managing SANs, you're already familiar with this concept. Disk virtualization simply means I am going to go carve off a chunk of space out of a SAN, and we're going to tell the SAN how redundant and how fast it needs to be and how resilient it needs to be, but we don't actually need to know where that drive exists. You can still carve out drives, drive 5, 6, 7, and 8, create a RAID 10 and go hand it off to a server. But most new modern SANs actually just ask you where, and then it manages where that is. It can move the data around from drive to drive physically in the backplane, so that it overcompensates for any kind of really heavy traffic periods and overutilization. Anyway, getting off the topic, storage pool, we're going to create it out of the storage pool we created earlier, and we get to make some interesting decisions on this. So really quick, I'm going to call this vert disk 1, and now we get to make some choices about our redundancy. So very much like if I were creating this on a RAID controller card, I would have some options sort of like RAID 0. This would be very close to RAID 0, or a RAID 1. That would be very, very close to a RAID 1 situation, or a RAID 5, data bit, parity bit, but instead we're going to have something that would be better described as data chunk, parity chunk. So maybe we want to have some redundancy from a parity standpoint in this case. And here's a really interesting part of this. I can either fix provision this, or I can actually thin provision this. Now, again, if you're familiar with SANs, this is not a new concept. To go create a SAN at a one-to-one relationship, buying disks and storage containers in a way that exactly matches what your end users are asking for is generally a waste, because people don't know a lot of times how much space that they're going to need, and they a lot of times ask for a lot more than what they need. A lot of times they're planning for the future. They're planning for a 5-year project. We're going to have this new we're going to have this new project that's going to need X amount of space over the next 5 years, and for the next, for the first 4 years of that project, even if they do actually use all of that space, you've got 15,000 RPM disks spinning in a SAN that cost you a lot of money with not one bit of data on them, right? So it makes sense to buy and let the SAN manage that. Monitor the SAN. As it starts to hit capacity, we can go and add more storage later, but we can present the amount of data that the end users have asked for, and then we can turn around and manage that capacity in a more realistic fashion. That's what we're doing here. Then provisioning. So we have these drives that we created here, and it shows a 72 gig or 71 gigs of free space, right? And we're doing this in a parity fashion. We're going to do thin provisioning. It's going to show that 71 gigs worth of data right here, right? But what I can say is I actually want to make 150 gigs, or maybe let's just go crazy. Let's go 300 gigs worth of data. Okay, and I'm going to create this virtual disk, and it's going to be a 300 gig LUN that just got created. Now, I can see this inside of storage spaces. I can look under my storage pools and I can see this storage pool 1, and I can see that we've created this virtual disk, and I can see that we have the provisioning type is thin. I can see the layout is a parity layout. I can come over here and I can see the capacity is at 300 gigs, and I've allocated a gig of it so far, and that is currently attached to MS2, and that it's made up of these 4 physical disks. But if I go into the device manager, I still see just these disks. Nothing really has changed, except we've now got this Microsoft storage-based device that has also been added into the picture. And if I go back even more interestingly into disk management, guess what I see here? Come down, this is a 300 gig drive. What about this shows me that this drive is anything more than a real honest-to-goodness LUN attached to this system that's got a capacity of 300 gigs. Well, nothing, just like if I had been handed this by a SAN. So this should give you another bit of evidence that this is actually existing at the store port volume manager layer. Okay, so this is a true disk management situation. This is not RAID 0. Okay. I can just right click and I can create a new simple volume on it from here, just like I always have, but I want to show you how to do this actually inside of the new console. So I got my virtual disk run here. I can run this new volume wizard just like I could in disk management. As you can see, we're poising, I think, anyway, I believe we're using storage management inside of the server manager to eventually replace disk management. Okay, so we were selected on this server and we're selected on this 300 gig disk. We're going to go ahead and create ourselves a 300 gig drive. We're going to go ahead and get this thing a drive letter as it thinks. This is it's thinking. Alright, we'll grab it. S drive for storage space. Now, we have a ability to do this as NTFS or REFS. So if you haven't heard, we have a new file system as of 2012. REFS is posed to replace NTFS in the future. Our new capacity for NTFS is 64 terabytes. We will have that as the biggest that NTFS is likely to get in its lifetime. There's a handful of enhancements to NTFS, so we haven't deprecated it. We've added a new check disk capability. It's not at the volume level now, it's at the file level, so check disks in Server 2012 will take about 2 seconds, whereas in the past it was completely dependent on how many files you had on the drive, so it could take hours or even days in some cases if you had a really big drive. Now, because of spot checking, which if I have time I'll have another episode where we talk about spot checks and things of that in the new NTFS health model. REFS is poised to take us into the future. It's a resilient file system, has a journaling piece to it, has amazingly large capacities, has tremendous file size capabilities and volume size capabilities. So you can create either of these. We're going to stick with NTFS for now, and we'll call this disk. We'll call this thin disk. Alright, and then next, and create. So, works very much like it would have been if we were just doing this through disk management. So we'll go ahead and let that go ahead and format. So I'll pause the video for just a second. And it's finished. Okay, so another couple of bits of information that are really cool about what we just did. Okay, everything about this is independent of the OS. So if I lose my operating system, I don't lose this thin disk. Okay, because there's a protective partition that exists at the beginning of this that actually identifies it as part of a storage space, as part of a storage pool, and it knows what it is. So when the system boots up after you have maybe had corruption on C and we had to reload Windows, S drive is still going to be there. It's still going to be thin provision. It's still going to be configured exactly like it is right now. We can use this just like we would, and we can hand out more virtual disks if we want off of that storage pool. So what I mean by that is I'm going to circle back around in here. I'm going to come up and I'm going to right click on the storage pool that we created, and I'm going to create another virtual disk. Right? So once again, thinking of that storage pool as part of a SAN. I'm going to go back in here. Let's say that this time we're going to create, let's say, vert disk 2. And this time let's make a mirror. And this time let's stick with thin. It's just because we're going crazy here. And let's say we got, this time we're going to do in 350 gig drive. All right. Great. And we can go ahead and check this box, create a new volume, just so I can kick that new volume wizard off and let that run. We're going to go ahead and create a 350 gig drive, which by the way has already appeared here in disk management. There it is. So again, a LUN appearing to me in the operating system, just like I would if it was on a RAID controller or coming off an HBA card or coming off an iSCSI target. It's block level storage just like anything else. We're creating this time as a mirror, so why don't we just pick M drive for fun after it finishes thinking. Keep thinking, keep thinking. There you go. Keep thinking, keep... Oh, aha, cool. LM. We'll call this M drive. And we'll call this mirror just for fun. Why don't we make this REFS just for fun stuff? Note that when I go REFS, generate short file names is grayed out. One of the things about REFS is it will not support the short file name, or the 8.3 as it used to be called. So I'm going to go ahead and let that go, let it format, and we're done. There we go. So now we look at this storage pool. We can see that we now have two virtual disks. One is Theron, one is mirror, parity, 250 gigs, 350 gigs, M drive, S drive. All we can see here in disk management is 350 gig drive. Looks normal to me. So what if we start running out of room? Well, we're going to start getting notifications down here in the Action Center. If we're monitoring this server, we'll be getting alerts. We'll be seeing that coming up in the event viewer. There's going to be a lot of places where we're going to know. And Windows knows that it's running out of space. If we've over-provisioned that drive, just like a SAN, it's going to start screaming at us. And it's going to start telling us. But if nobody pays attention, the SAN simply will eventually shut down or cease to allow you to write to that. The neat thing about doing this in Windows, not to put this up against a full-featured SAN, but the neat thing about having done this in Windows is going to be that, well, Windows knows that there's a problem coming up. It can do more graceful shutdown against these disks because it knows of the problem prior to the problem happening. Okay, so this is some kind of cool stuff. Well, what happens if we do see that start to happen? Well, one of the things we can excuse me, one of the things we can do is right-click and say add a physical disk. Well, we've got this 20 gig drive right here that we hadn't assigned earlier, so I can go ahead and add that into the pool. All right? Notice that the primordial pool just disappeared. The reason for that was because there's no unconfigured disks now. We would see the 20 gig drive that was listed here a minute ago has now disappeared, all right? Because it's now been absorbed by the pool. And let's say I go in here to File, Settings. We'll come on over here to the SCSI controller, and let's go to hard drive and add another one. Let's create a new little virtual hard disk, and we'll make a VHDX. By the way, you know what? Actually, I'm not going to go here yet. We'll talk about this a little bit later when I get into some Hyper-V stuff in a later episode. We're going to create a dynamically expanding disk. We'll call this disk 6. We'll make this one. Let's make it 22 gigs. Actually, let's make it 24 gigs after Jeff Gordon, my wife's favorite NASCAR driver. Next, finish, and there we go. So we've got another drive. I'm going to click OK. So we should have a primordial pool again up here. Note the refresh button. Make it think, thinking, come on, think. There we go, primordial pool. There we go, another drive. Right click, add a physical disk. Take this guy, shove him in there. Might make him a hot standby, hot spare. There we go. All right, so all kinds of really awesome stuff that we can do. I'm going to show you where you would see whether we added that in. See, this is automatic hot spare. This stuff can now float around. I've got two virtual disks. One is 250 gigs. One is, what was it, 350 gigs? Now I can't remember. I have such ADD, I can't remember from 1 minute to the next what I'm doing. There we go. So, scenario being, I've given this disk out to one group of users and this disk out to another group of users. They claim they need 300 gigs. They claim they need 350 gigs. If these people actually start getting where they're using this, we'll start actually having to add some disks over a period of time. These people may have said they need 350 gigs and they put 20 gigs of stuff on here, and there's never anything more that actually goes into that, right? If you've been in IT for a while, you know that's how things work. Why waste money on disks when you don't have to? Watch this, monitor this, and then only give out what we actually need to give out at the time we need to give it. And here's another thing about what we've got. See, you can tell what types of disks we've added in because these are all SCSI. There are SAS drives as well supported in this. SATA drives can also go into here. USB drives. You have all different kinds of storage interconnects can be mixed. Now, it needs to be block storage that is not network. In other words, no HBA fiber channel type stuff, no iSCSI can go in here because those would assume that we're already pulling those from another intelligent storage subsystem, so it doesn't make sense to then shove it into another one, right? Disk virtualization on top of disk virtualization just might be a 2-bit chaotic type of situation here. We will support some configurations of this in cluster, by the way, but it would have to be shared SAS, which is fairly rare, and as a result, you're not going to see a whole lot of implementations of that type of thing. But anyway, we would be able to add different storage interconnects of different sizes, then provision this to create a pretty robust situation. I'm going to show you some other cool things in Windows Server 2012 storage that are coming up in some future episodes where you could see where you could combine this disk virtualization with some other things like data deduplication and some other neat things that you could do that might be some pretty good tier 3 storage solutions, tier 2 storage solutions. Even in some customers, this might make sense as a tier 1 storage solution. So anyway, guys, this has been Chris with Microsoft. As always, thank you so much for working. If you did find anything about this useful, please give it a quick like in the thumbs up link below, and feel free to subscribe to my channel. I'd love to have some more subscribers into my little YouTube channel here. My blog is at 9z.com. It's incredibly easy to remember. It's just the last number, it's the last letter, .com. And it has links to my Facebook, LinkedIn, Twitter, and a bunch of random posts from time to time that I throw out there. So anyway, as always, thanks a ton for listening, and I'll see you guys in the next episode.